Greetings, Honors Pre-Cal students. This lecture is going to explain, hopefully, what permutations and combinations are. And to start off talking about permutations, we're going to do a quick example. How many different pizzas can be made if you have a choice of 3 crusts, thin, regular, and thick, 2 cheeses, provolone and mozzarella, and 4 toppings, pepperoni, sausage, mushroom, and green pepper? And we're going to assume, for the sake of simplicity, that each pizza can have only 1 topping. Okay, so the best way to think about this is that I've got 3 crusts. So under crusts, we have 3 choices. We have 2 cheese choices, and we have 4 toppings to choose from. Okay, now if I take one of these, it can work with either one of these 2 cheeses, and either of these cheeses can work with any one of these 4 toppings. So what we're going to have to do to get our total number of choices is multiply all of these together, and so we end up with a total number of 24 different pizzas. And I'm not used to using this pen here. Hopefully I'll get a little better as the day goes on. Okay. Now, we just illustrated the multiplication principle of counting, which says that if there is a sequence of choices in which there are P selections for the first choice, Q selections for the second choice, and R selections for the third choice, then these selections can be done in P times Q times R different ways. So let's look at our next example. How many 5-letter words, including nonsense words, can be formed from the alphabet? Well, if I take the first letter, I have 26 letters to choose from. That leaves me with 4 more spaces to fill. I've already used 1 letter in the first slot, so I have 25 to choose from here, and then I have 24 to choose from in the third slot, 23 in the fourth slot, and then back down to 22. If we use our multiplication principle of counting here, I'm going to multiply all these together, and believe it or not, we're going to end up with 7,893,600 different words that can be formed from the alphabet. Now notice that I didn't do any repeating in here. So what does that mean? It means that a permutation is an ordered arrangement of n distinct objects without repetitions, no repeating. And the shortcut to describing this situation is Pn, R, which means the number of n distinct objects taken r at a time. Sometimes you'll see it written like that, NPR. Now the shortcut to doing that is to take n factorial and divide it by n minus r factorial. 3 things have to be true for you to be able to use this formula. First of all, the n objects are distinct from each other. They're not the same thing. There is no repeating of any objects, and the order is important. So in other words, the letters A, B, C is a different word from B, A, C, and both of those are different from the word C, A, B. You can use your calculator to compute permutations. For example, if I wanted to do P10, 6, then I can go to the calculator. I'm going to put the 10 in first, then I go to Math, arrow over to PRB for probability, and check it out. Number 2 is permutations. So I do 10 NPR 6, and that's 151,200 permutations of 10 objects taken 6 at a time. Okay, So that's what permutations are. Let's talk about combinations. A combination is like a permutation. The only difference really is that order is not important. So in other words, that ABC, BAC, and CAB, those are all the same combination now. This formula is a little bit different. Because these are all the same combination, they only count as one combination, so we're going to have fewer results for combinations than we do for permutations. A combination is the number of terms divided by how many you're taking at a time, subtracted from n, and then that's multiplied by the number of terms you're taking at a time. So here's my question that we might use combinations for. How many different committees of 10 students can be formed from the class of 2011? Now think about this. When you have a committee of students, does it matter what order the students are chosen? It really doesn't. So we wouldn't want to use permutations for this example. We're going to use combinations. Now there are 81 seniors, and so we're going to choose 81 taken 10 at a time. Let's use our calculator for this, okay? So I'm going to go 81 math PRB, and this time I'm going to use number 3, the combination feature. And we end up with, wow, that's a lot, 1.8784 times 10 to the 12th different committees that can be formed from the class of 2011. Okay, so that's pretty much it for permutations and combinations. What I'd like for you to do now is get your worksheet from the shelf in the room, or you can download it from Moodle and begin work on that. You're welcome to work on it in groups or with a partner, and that will be due on Wednesday. The next lecture coming up is on probability. Good luck with permutations and combinations.